guys, today we'll be finishing the sequences in series chapter for the test. This is the last example 6 of 10.2 is the last section that will go in the test, and that's pretty much the sum of arithmetic means. Now there are two new formulas which are variations of the ones we learned yesterday. The first one is used when I have a finite arithmetic sequence and I want to find the sum of all the numbers between those two numbers. Okay. The second one, which is a bit more complex, is used when you want to find the partial sum from here to here or from here to here of an infinite sequence. And you'll see how they both play out. Depending on what information they give you and the situation, you might have to use different formulas. Now, in the first case, they say find the sum of the arithmetic. So it says find the indicated sum of each arithmetic series. This is the first one that they give me. I have to find the sum of all the elements from -5 to 317. Since it's not partial, it's all of them, I'm going to be using the first one. Now note, for this one, I know what my first element is, but I don't know what my n is. I know what my last element is, but I do not know what my n is. So how do you find the number of elements? We work slightly backward and use the previous formula you learned, the basic one. Now in this formula, I know that my first element is -5. Plus, I do not know how many elements are between those two numbers. I do know that my difference is 7. It goes up by 7 every single time. And I do know that the nth number is 317. All you have to do now is isolate the n to find the n. First you add 5, this becomes 322. Then we divide by 7, that becomes 46. So you end up with something that looks like this. Then you add 1, and the number of elements equals 47. Now that is important because I will be using that n to plug in here. Now that I know that my n is 47, let's start plugging in the values. Pretty much, the sum of the sequence will be 47 divided by 2. Again, the n I just found, the first element, and the nth element, or term. I'm saying element, but it's term, the nth term, which is 317. Add that, multiply, divide, and you're done. And you end up with this number, 7,332. That is the sum of all the numbers between this and this. Okay, pretty straightforward. Now, let's look at part B of example 6. They're asking me find the 28th partial sum, and usually you'll see the word partial when you have to use this one, of 27 plus 14 plus 1 plus infinity. Now, let's begin plugging in the values. I do know that the sum will be 28, because that's how many terms I'm going to be adding, dividing by 2. I know that my first term is 27, even though if you read the book, or the particular edition of the book that I have, it says that the first term is -5. The first term is -5, that's what it says in the book. But that's referencing to part A, so there's a mistake there. The first term in the sequence is 27. Okay, so again, 2 times the first term plus, I know there's 28 terms. 28 minus 1 is 27. And the difference between these terms is -13 times -13. I'm going to close that off. All you have to do now is multiply, again, proper PEMDAS. Multiply these two, combine those two, and then multiply by that fraction, and you're done. So in this case, there's no need to find how many terms. You just plug the corresponding values into wherever you have to plug them in. This is how many elements. This is the first element. This is how many elements. That's the difference between elements. Plug it in, calculate, done. The answer here is negative 4,158. That's what happens when you begin here and you add the first 28 numbers, including 27, of course. Now let's go over the last example, part C. Again, today is pretty short and sweet. That will give you more time to do homework. There's not going to be a lot, don't worry. Part C, we're seeing sigma. Again, remember, that means summation. This is the formula here, 5n minus 17. This is the lower bound. It's not actually the lower bound, remember, it's the index, but I just like to say this is the lower bound because it's the bottom, and this is the upper limit, it's at the top. Now here, you just have to do a little bit of calculating, and that's it. But we will be using this formula. And look how easy this is. First, let's find the first element. So for the first element, I plug my n of 6 in here. So 6 times 5 is 30, minus 17 is 13. So I know that my first term, is 13 due to this formula they're giving me. Now I want to find my last term. You plug 28 in here. 20 times 5 is 100. 8 times 5 is 40. Add them, 140. Minus 17. 140 minus 17 is 123. So you know that your 28th term is 123. Now, one thing that many students get confused is, in order to find how many terms there are between these two, many students say 28 minus 6. That gives you 22. It's close, but it's not correct. You have to count the 6 as well. So again, let's see. 6th term, 7th term, 8th term, 9th, 10th, 11th, 12th, 13th, 14th, 15th. That's 10 terms already. 17, 18, 19, 20, 21, 22, 23, 24, 25. Lo voy a hacer de nuevo, perdón. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's 20, 26, 27, 28. So there are 23 terms. Again, I counted 23 terms. There are 23 terms between these two. So your n, how many terms there are between those two. Now let's start substituting in here. Your n is 23 divided by 2. I know that my first term is 13, and I know that my 28th term is 123. Add it, multiply, divide, calculate, boom, you're done. The answer is 1,564. When you look at the answer in the book, it's even faster. But no, it's not that difficult. Again, just plug the values in, calculate a little bit. All you have to do here is calculate the first term, calculate the last term. Make sure you, again, one way to do this is just subtract these numbers and add 1. 28 minus 6 is 22. You add 1, 23. That's how many terms there are between them. Now, look at it this way. 7, 5. 7 minus 5 is 2. You add 1, 3. And let's see. I add the 5. I add the 6. And you have to add the 7th term. So that's 3. Remember, when you add these numbers, you have to include the first one and you have to include the last one. They are included in the sum. They're not, outside boundaries. They're included, okay? And that's pretty much it. Now for homework, example 6, please do 39, 40, there are no sigma exercise. I want to see, do 39, 40, 46, and 47. Only 4. 1A, 1B, and 2C's. So again, to repeat, do 39, 40, 41, sorry. And 46 and 47. Finite sequence, partial sum, 2 sigmas. That's it for homework. So tomorrow, Wednesday, is going to be a full review day. I'm going to just upload some practice exercises and a video that will tell you what's going to show up on the test. Now, normally, I give you guys Fridays off. What we're going to do this week is I'm going to give you Thursdays off, and we'll have the quiz on Friday. That gives you an extra day to study. Unless 100% of the class wants the exam on Thursday. If everybody wants the exam on Thursday, no problem. I'll just give it to you guys on Thursday. But what we'll do is, I'm thinking I'll give you the extra day Thursday off so you can study or rest. Then we can have the exam on Friday. It is going to be a quizzes exam, so there is no need to reserve a spot. I will also be uploading exactly what you need to review tomorrow, because again, tomorrow is going to be a lot of exercises, but it's a practice day. You don't have to upload all those exercises as homework, but I do recommend you do them all for the test. If you have any questions, you can let me know. So tomorrow you'll get the details for the test. Exam on Friday, unless absolutely everybody wants the exam on Thursday. If there aren't any other questions, well, if there are questions, let me know, because there's no way to know right now. So have a great day, and I'll see you soon.